Unit 5 is all about solving polynomials. So this first task that we're going to do is we're going to solve a polynomial by graphing. And before we got started, I wanted to show how, so once we get going on some of this material and it becomes more difficult, sometimes students struggle to understand, why do I have to learn this? And so, give me just a second here. I showed in class that here is an example of where you might use it. Not saying that all of you will, but you might use it in this situation. So here you can see where you had a nice sculpture and they weren't sure how much to shave off. So that's why they have all of those binomials with those X's in there. And then this is exactly how we're going to use our graphing calculator so that we can come up with what does X have to be so that they can come up with that horse shape. So going back to over here, we're going to use our graphing calculators to begin to know where I can find my answers at. Okay, so just like before, we got to make sure that it says y equals, so you want to make sure everything is shifted to one side. So I went ahead and I added my 4x to the third over here to this side, and that's where I got this polynomial. And then I'm getting ready to plug it into my graphing calculator. So remember, you want to hit y equals, clear out anything else that's already in there, and then start typing it in. So x to the fourth. Remember, your exponent button is this guy here, your caret key, to the fourth, plus 4x to the third, plus 3x squared, and then minus 5. And then I'm going to hit graph so that I can see kind of sort of what my graph ends up looking like. Now, same question we had before. If I'm solving, where are all of my answers? The zeros, the roots, the answers are all the same for finding where it crosses the x-axis, so your x-intercepts. So you're going to go to second calc. We're going to hit that 0 button, so number 2. And then we're going to make sure we're left and right of each 0. So in this case, I can see that we're going to have 2 real answers. So I'm going to start with this guy over here on the left. There we go. So right here, my cursor would be left of my x-intercept. So I'm going to hit enter. I'm going to hit my right cursor so that I am right of that guy, and then I'm going to hit enter again. And so I get one of my answers to be at negative 3.22. This guy here is in scientific notation, so that just means 0. Okay, now I get to do it all over again because I have that second 0 over here on the right side. So I'm going to make sure that my cursor is left of that guy. So here it would be left of it. I'm going to go right, and then I'm going to hit enter. This is nothing new. We have done those 0 functions before. It's just applying them to a polynomial. So making sure you're doing it however many times that it crosses that x-axis. So in this case, I would have 2 answers because I'm crossing 2 times. Pause the video and try the next question. So on the next one, you should have moved that 1 over by subtracting, and you should have gotten 3 of those zeros. So if I type it in real quick here, this is what your graph would look like. And so yes, you're getting 3, 1, 2, and 3, and making sure you're going left and right of each of those zeros. Okay, so then the other part is we are going to apply this to some word problems. like we did before where it had that ice sculpture. These polynomials are applicable to stuff you're doing in life. Whether you decide to use it or not, it's kind of up to you. So here's the scenario. The Association of Zoos and Aquariums provides information about proper animal care and management. The AZA, which is just this, states that for an exhibit with 6 or fewer emperor penguins, the pool must have a depth of at least 4 feet and a volume of at least 1,620 gallons, or about 217 cubic feet per bird. If a zoo has 5 emperor penguins, what should the dimensions of the pool shown at the right be at the minimum requirements? So it's showing me this is my height, this is my length and my width. It's showing me here's the pool and I have 5 penguins and I have to make sure that my pool is big enough to have all 5 of those in there. So first off, I see the word volume. So that tells me that I'm going to be using this volume formula for a rectangular prism. So going back to geometry, volume equals length times your width times your height. Then I also see that my requirement is 217 cubic feet. Now they give me these gallons, but that's not helpful because I don't measure length, width, and height in gallons. So that's why you're going to end up using this number and not that number at all. Okay, now this said it was per bird, so that's why I have to take 217 times 5. So I know my volume has to be equal to 1,085. And I also know to find the volume, I take my length times my width times my height. And that's exactly what I did. I just set that up as a polynomial. Okay? Now what I'm going to do is I'm just going to type that into my calculator. But remember, just like we did before, we have to make sure it's equal to 0. So I'm going to minus that 1085 over. And I am not going to take the time to simplify this because my handy dandy calculator will do it for me and graph it all at the same time. Okay, so I'm going to have 2x plus 3 in parentheses. And then I'm going to do another parentheses, 5x minus 2. And then I've got 2x, and then I've got minus 1085. And I'm going to hit my graph button because what I'm doing is I'm trying to figure out what does x have to equal so that I am having my minimum requirements of that pool. So I'm going to find my x value, so my 0. So I'm going to go to second calc, go to my 0, and then I'm going to go left and right of this guy here. Now this is where it gets a little complicated. Remember, if I have an x-intercept, my y has to be equal to 0. So that means I'm clear up here since it's 1905. So I'm going to hit my left arrow until I get closer to 0. See how it jumped to the negative right there? So if I go to the right, it was positive. If I go to the left, it was negative. So that means to be left of this guy, I would have to be here. And notice where my arrow goes. So that kind of confirms where it needs to be. And now I'm going to click right. Even though I can't see it, I know it has to be right above this x-axis. So I'm going to hit enter again. And then I'm going to hit enter and find that my x has to be equal to 3.5. Now, I know this is uncomfortable because you're going in blind, but pay attention to your y, right? So if I'm going to have a 0, that means my y has to be equal to 0. So if I'm in the negatives, even though I can't see it, and I hit the cursor again and then I'm in the positive, those are the 2 spots that I need to be. Now that I know what x has to be, all I have to do is just fill those in for my different expressions. So I did 2 times 3.5 plus 3 to get my length, and 5 times 3.5 minus 2 to get my width. And then I did my height 2 times 3.5. So those would be all of my dimensions that I would need for this minimum requirement. Okay, so you're going to pause the video and you're going to try this next one. So after you have this next one, you notice that we're doing area this time. And it looks like the room is in the shape of a rectangle. So remember, for a rectangle, I'm just doing length times width to find my area. They already told me what my area has to be, 195. They told me what potentially my dimensions would have to be. So I'm going to do my length times my width. I'm going to subtract my 195 over, and then I'm going to plug it into my calculator, just like we did on the other guy. So I have x squared minus 1, and I have 3x plus 1, and then I minus my 195. Oops, looks like I was typing over some stuff. There we go. Okay, remember you want to find what x equals, so that is your x-intercept. So I'm going back to calc, I'm hitting my 0. My y currently is at 189, so I need to get that closer to 0. So I'm just going to hit my left arrow. Now I can see it, so I need to be left of my x-intercept, which means I need to be 1 down. So that's why it's putting me in the negatives, and I hit enter. If I go right, I can see it. That's where it would be enter, and then I get my answer. So my x would be equal to 4. Then I just plug it into my different expressions, and that will give me my different dimensions. So 3x plus 1, when I plug in 4, I get 13, and x squared minus 1 would give me 15. All right, folks, so that's where you can solve polynomials in the real world, and then also be able to solve it by graphing.